This is a first in a series of videos outlining how the new feature extraction tools work in n4ce. I'm sure our way of doing things is different to other people's, so what I'm going to do is I'm going to go through different ways of extracting data depending on what it is you're extracting, and I'm going to start with road markings because they're the easiest and then kind of build up from there. So the idea is that you're going to watch the videos in turn and they'll build on each other. So the feature extraction tools are under a new tab called feature extraction, and they are a bolt-on to Designer. They are not standard as Designer functions, they are a bolt-on. Once you've got the bolt-on activated, then you've got these four icons initially, and more will follow in time. But you basically have to essentially choose the kind of class of object you're trying to extract. For this video, I'm just going to extract road markings. So I'm going to select the road markings tool. Okay, so all the tools here down the side essentially customize various variables in the auto extraction routine. You can think of the routine as essentially a hungry caterpillar which has got a blindfold on. And what we have to do is we have to define some sort of metric that's going to guide that caterpillar as he takes his or her mouthful. So I'm going to go through these items now one at a time. Some are more important than others, and then try and do some extractions at the end of it. When you do arrive at an extraction or a set of presets that work, then obviously you save those presets, and then obviously ideally export them as well using this button up here, so that if you want to, you can then share them with anybody else. So other people in the office who've also got the feature extraction tool don't have to go through the same learning process or tweaking process. You can literally just give them the settings that you're working with. The first option, then, remove noise. So this is really only used if your data is very, very, very noisy. Most point cloud data these days is actually fairly clean, and that all that does is really essentially tries to remove spurious points before we actually go into any kind of algorithms. So generally we don't need that one, don't need to worry about them or worry about that one. So the next option then, output point spacing. That's essentially allowing us to configure how close you want the points when they are extracted. Simple as that. It's not guaranteed to be that value because there will be some line simplification working in there as well, but it's a target. So if you want points output every meter or close to every meter, then put that value in there. Obviously with the road markings here, point every meter is probably over the top, so I'm going to just change that to a point every 5 meters. Under there we have a clustering then. So if the data has breaks in it, so it is not really applicable so much for roads, but if it was for, say, extracting cables and there's shadows in the cable or there's gaps in the data, which quite happen sometimes with cable data, so the data can just appear and disappear for whatever reason. This clustering helps glue it all back together again, and that's the kind of search distance between the points to sort of glue them back together again. But I'm going to disable the clustering for this because it'll basically it's unnecessary and it will slow it down. So you disable it just by putting 0 in there. The maximum distance, that's if you want to work in particular chunks and you don't want it to carry all the way on through, you can put a value in there. So you can say I want to pull out 500 meters worth of data, in which case you just put 500 in there. If it can't find any valid data when it's working, then the prediction routines come in, and a redirect essentially is a prediction, and you tell it now, or you tell it here, how many times to bother trying to guess where to go next. When it does do a guess, you can tell it how far to look ahead when it does this guess. So it's looking ahead when it does a redirect. So if there's a gap in the data, like you can see over here, if I jump to this data here, there's a gap in the data, and there's a few gaps in the data, in fact. So if we want to, we can increase that redirect length so that we have a chance of essentially bridging some of these gaps. The problem is if you make the redirect length too large, it can jump to a different track or a different white line, or jump onto another object that you don't really want it to. So it's a kind of balancing act, this one. So redirect length of 2 meters is usually about right. 10 attempts is probably OTT, so I'm going to just drop that down to 5. As the routine is looking, as this hungry caterpillar is trying to establish where to go next, we need to tell it essentially how far left and right it can move and how far up and down it can move. So that's what we're doing here. So this DZ toll is essentially saying along the search distance, which is down here, how far to look up and down and left and right. So we start these off with basically creating a seed. So I'm going to do that now. So I'm going to add seed, and let's start, it's back here somewhere. Control click to zoom in, and let's see, start here and go that way. Okay, so now I've got my seed. This DZ toll, so that's the delta Z height change essentially. So this arrow that's now locked to the scan, basically what we're saying is how far above and below that arrow we should be looking for data every time we essentially make an attempt to find out where to go next. So each time this caterpillar takes a bite, it's taking a 2 meter bite, and it's also going to go left and right 0.1 of a meter and up and down 50 mil basically. So depending on how noisy the data or how wide the data is, you can increase and decrease these values accordingly. I'm going to increase that a little bit to say 0.15, and underneath that we have the DZ change per meter. So if you're going uphill, that fixed value there could basically end up stopping the algorithm because it wouldn't allow it to go up at any kind of angle. So what we can do is we can also basically modify this DZ change per unit distance so that it can it be allowed to look up and look down a little bit more than just that rigid value there based on how far it's looking. So I'm just going to put 0.05 in there. Again, these are educated guesses, and as I said, the search distance. So every time it takes a chunk of data, or every time it tries to take a chunk of data, it's working in 2 meter chunks. Now, if I just quickly go to the tools menu and go measure distance. So these arrows, so these white lines are approximately 10 meters apart. So if I actually use a 2 meter search distance, it's going to struggle straight away because it's not going to find any data. So I'm going to up that to say 5 meters. I could make it go further, but 5 meters should be enough to get it to find some data each time, especially with the redirect in there as well. The fine adjust for height radius, so this is essentially tidying up the data. So once it's got all the data in it, it'll put a best fit line through it. So that best fit line works in plan, but it also obviously has to work in height. So what it'll do is when it knows where the points are in plan, it says, right, now what do I do about the heights? And this allows us to smooth out the heights, so it works within that radius around each point that it's decided it wants to keep in plan. So that our spacing, a 5 meter spacing, but it'll only go up and down, in this case 0.2 of a meter, so it doesn't essentially, so I don't know, if it was a multi-story car park, end up going to a different floor. Obviously for this data here, that value is kind of irrelevant because we haven't got anything above or below it, but it could kick in quite handsomely if you're working with multi-level data. And fine adjust height only mode basically means that the data will only smooth out the height, or rather the best fit line will be not smoothed in plan. All it'll do is it will just smooth out the heights. The grid spacing allows us to deal with overlapping scans and density changes throughout the data set. So it doesn't matter how many scans you've got in one place or how many points you've got in the scan, it'll essentially de-resolve the data to a fine grid. So automatically as the routine process is. So I'm going to set that to 2 mil. So line color isn't actually activated yet or isn't implemented yet, but line intensity is. We haven't concentrated so much on line color because the colors can change quite dramatically depending on scan or scanner, time of day, lighting conditions, whereas the intensity seems to be more reliable. so that you don't have to guess what value to put in there. I'm just going to scroll down here, come down to pick intensity, and then just hover over the white line and pick it. Okay, so what n4ce has done now is it's now adjusted the data so that just the points that have that intensity or greater are selected, or rather shown on screen, and that value has now gone in to here, this 9,000. You can change it, so once you know roughly where you are, I could say, well, if I drop it to 8,000, what happens? Still good. Drop it to 5,000, still good. Okay, so that's not necessarily the absolute value. Depending on what you're working on, depending on what you're trying to extract, you might want to play with that value so that it doesn't end up pulling out more data or the discounting more data than you otherwise want it to. So having put that intensity in here, I can actually tell now that I can actually move my original seed back. So I'm going to right click it and choose move, and I'm just going to drop it to here. Having done that, I need to re-rotate it and just point it in the right direction again. There you go. So that's that one. That's that one done. And I will add another one whilst I'm here. Let's go from there to there. Okay. So this is what tells the algorithm what direction to sort of initially head off in. I'm not going to do these ones on the side just yet because they will probably require slightly different settings, especially as this one here has got a bit more noise around it. So I might need to up the intensity to get that one to pull out properly. So after the intensity, we've got the Douglas-Quirker tolerance. This is line simplification essentially. So the smaller the value, the less simplification is made. The larger the value, more simplifications are made. If you imagine a triangle, and essentially the midpoint is that distance away from the first and the last point. If it's greater than that value, it's kept. If it's not, it's just removed. When we are pulling out this data and we're working in chunks of whatever the search distance is set to, at the moment I think it's 5, I said a 5, yeah. So when it works on these chunks, it analyzes each chunk and tries to best fit some sort of line through it. So it's using least squares algorithms to try and put either a curve through it, a polynomial, or a simple straight line. And it will do multiple best fits, trying to figure out what sort of line fits it the best. And these tolerances help decide when enough data has actually passed the tolerance to actually be worth keeping. So the coefficient here, the minimum coefficient, this value in an ideal world would be 1, which would basically mean that all the data in that last extraction is perfectly in line with the polynomial that was essentially best fitted through it. So obviously that's unlikely, and all we want is points that are roughly going to follow the trend. It doesn't have to be absolutely perfect. So ideally that would be around 0.8, 0.9, but it tends to not need to be so high, so I tend to relax it to about 0.6. And the standard deviation and the maximum standard deviation, essentially how far off that theoretical are we allowing data to be kept. So this white lining is probably about 100 mil wide. So again, giving it a bit of tolerance, I've made that a little bit wider. Anything outside that just won't be allowed to continue or won't be added to the data set. And get mean height over length. So when we're pulling out data, the next arrow, should we say the next seed, it needs to know where to go next. So it's trying to figure out in plan and in height. And this value here controls how much of that last chunk of data from the end of that data should be used. Try and set the height of the point. So if you let it to 0.01 or something like that, then you are relying on those end points being valid. Whereas if you widen it a little bit, say half a meter, then it takes a sort of trend over that last half a meter to determine the kind of inclination of where to go next. So again, it's just a way of smoothing out noise, smoothing out error, and helping it to decide a best course of action and where to go next. If the clustering were turned on, which is not, essentially, basically, if it finds a short cluster, it says basically if it's less than that length, then don't bother using it because it might just be noise. But again, that's not really used that much. The markings here, find the gaps, the road markings, that's not implemented yet, but essentially what that will do is hopefully give you points either end of the dash rather than just essentially a best fit line through all of them. The debugging I'll discuss in a minute. So all I'm going to do is just hit extract. Okay, so we've got 3 seeds in here, so I left one in here. So I'm going to reset that. And I'm going to clear all my seeds and start again. That. Add that. Okay, and try and extract. Okay, so this one's quite happily going off. Now then, I'm going to increase my search distance, say 7 meters. So I've repositioned my seeds, and I'm going to try and do the extract. Now that one's carrying on quite nicely. This one hasn't got very far at all. Okay, so what I'm going to do first of all is just say, right, let's have a look at the other one. So if I double click number 2, so that has gone off up into the banks, and it's done so because essentially it's encountered a lot of noise around these white line segments here. Later releases will actually allow us to weight the data based on its intensity. So at the moment, the only way to fix that is just to change our intensity value, and I deliberately set it low so that I can show what happens if you have it too low. So if you put it to 8,000, you see the data gets much cleaner. So reset. Now this one here probably gave up straight away because it didn't find enough data. So I'm just going to move it to here and just tweak the rotation, and now see what happens. Okay, so that one stopped at the gap there, which we kind of assumed it would, which is good. And this other one now is getting on quite nicely. Okay, now I've sped this up a bit so that we don't have to wait right for the very end. But when it gets to the end and stops, it shows me that that's got to that point there. And if I double click C2, you can see that's made it all the way down to here. But to make life a little bit easier to see what it's done, I'm going to just turn off some of this debugging data. So the frustum is essentially just when it has a guess, it just shows you the area that it was guessing in. So that's done quite a nice job and essentially has stopped pretty much where the data stopped. So that's worked very nicely. I double click number 1. That stopped because, as you can see, it ran out of data. These red lines are the rays. These are what are essentially cast out. I can turn them on and off. When it's looking, it essentially uses the ray to decide or indicate where to go next. So what I'm going to do now is say, well, if I double click number 2, and this one here, give it a code. I'm just going to say RD for the time being. Oops, RD. And right click this one and choose commit and remove. So there's the data now, that one's in. If I go back to number 1, you can see that the data is nice and hasn't been, so it isn't too bad. It follows the lines as it should. We've got a little bit of an issue here where it's jumped up into the coach, and I could actually probably get rid of that just by tweaking this DZ value here. These are change per meter. If I got rid of that and lowered it, that might actually stop it jumping up into the coach. And later releases will have tools to essentially smooth that out anyway. So that's only a temporary thing. This arrow here, I'm going to commit and continue. There we go. So committing that one, it's finishing there. So what I'm going to do now is move it to the next starting point, which is probably going to be somewhere here, and then rotate to there. That done. I've only got one seed left, so I can just click extract, and off it goes. Okay, right click, commit and continue, right click, move to there, and essentially repeat. Okay, so having reset that second seed, hit extract again, and off it goes again. Commit and continue, move it to there, rotate it, and try again. Okay, so eventually that process just continues throughout the job, committing and continuing as and when it gets stuck. And now I'm just going to commit and remove. So you can see quite nicely the extraction routine has worked, pulling out the white lines quite well. And when you get your settings set the way you want, so you're getting acceptable results, put in a name. So I'm going to call this one dashed 7 meter, and then hit save. And that's now saved within the settings, so that I can essentially use it again and again and again, come back to it, and I'll get the same results every time. If I now look at that data in the modeler, here it is here, with points, hopefully at around 5 meters. There you go. And that concludes our first video.